Greetings, this is Artie from Artifact Electronics. Today we're going to have a look at this disk drive. It's a model 8050 to be used with the PET, and I guess if you have the proper interface you can even use this from a C64 or a VIC even. At least that's what the internet tells me. But this came along on a chance just after I finished the PET itself. And it was funny because why did I get it? Well, first of all, it was cheap. Second of all, the PET needs a disk drive. And one of my viewers asked me after the PET was done, now that this thing is fixed, what are you going to do with it? And my flippant answer to that was, I'm going to get it a disk drive. So here we are. We have a disk drive. It has an interesting history, and it was totally non-functional when I got it. But let's talk a little bit about the drive first. So the model 8050 had two drives, single-sided in it, and it used the IEEE 488 bus to connect to the Commodore itself. If you pick up one of these, make sure you get a cable with it. It seems that these cables, they're kind of odd because it's got a card edge connector that fits into the computer, and then a standard IEEE 488 connector that does fit into not only the disk drive but other standard things like some of the older HP equipment have the same kind of plugs on here. So it'd be probably a cool project to write basic programs to talk to an HP power supply. Anyway, that's for some other time to be done. But I was looking on eBay because initially I didn't get this cable, and at the time of filming there was one on eBay and they were asking $99 for this cable. That is more than twice as much as I paid for the whole thing. Fortunately, I contacted the seller and he said that he had a cable and he would throw it in, so at least the thing was hardware complete. It does have a somewhat interesting story. I mean, I got this from a seller, let's call him seller 1, who in turn got it from yet another seller, and let's call them seller 2, kind of the first derivative. But what happened was seller 2 supposedly found a whole bunch of Commodore equipment, computers, disk drives, printers, and stuff like that in the trash. Now, I don't know if it was actually sitting in a trash container or the side of the road or buried under bushes next to the railroad tracks, but he brought the stuff. Seller 1 bought it all from him, but the stuff was obviously filthy. Rusty, filthy. There was all sorts of foreign materials inside, and it wasn't a pleasant sight to see. But it was cheap, was a disk drive, and we don't say no to a challenge. So first, let's see what the current state is. And that is, let me flip the power on it. And if you watch the LEDs, it's doing a self-check, and it's basically telling us that everything's hunky-dory. And that's great, but this only comes after many hours were put into this. So let's crack it open and have a look inside. So this has two screws, one on each side, and once they're removed, just like the PET, top swings open and reveals the interior to us. And we'll have a closer look at things, but this is the overall view. One other thing I should mention is what's kind of impressive about this. These are just regular drives. These are MPI drives, as used in many other computers of the era. But Commodore used a special way of writing to these disks, making them completely incompatible format-wise with anything else. But they're single-sided drives, and they're getting 1 megabyte of storage per drive, which is pretty impressive for the time. And you could also get the model 8250, which had the same drives but double-sided, so each drive held 2 megs. And I think they achieved this by using variable bit rates, putting more data on the outer tracks than the inner tracks, but I'm not exactly sure about it. But here you go. So let's get a little bit more into detail. Unfortunately, I don't have any footage of what this looked like when I got it, but it was so gross inside that I didn't even bring it inside the house. I left it in the garage and took it apart, took out everything, and just tried to clean it up. It was, as I said, it was covered with foreign materials. There was rust on the outer case, which I've removed, and there was all sorts of stuff, interesting stuff inside the drives. But I'll tell you about that later. So let's look at the electronics first. So it looks like to me that somebody made an attempt to clean up the main logic board, because compared to the rest of the machine, it looked kind of clean. Now it has that characteristic haze on it, which can, if you look at this part, I think this was covered with, must have been covered with a sticker or something other, because this stayed green and this basically turned whitish green with the solder mask peeling off, as you can see over here. And this is, I've experienced this myself, is when you take a severely contaminated board and you bathe it in IPA and you brush it and you hose it down, while it's still wet, it looks pretty good. It looks like you got it all cleaned up. But the minute it dries, you get that white haze all over the board, and you can never get rid of that anymore. So, but somebody did make an attempt at cleaning up this board, and pulling a chip and looking at it, I think what happened was they pulled every single chip and they cleaned the legs on it. And they probably cleaned the sockets too, and put it all back together again. I think that went a long way towards me getting this thing to work. But again, the way I got it, it didn't work. The PCB is very interesting. As you can see, it's got 3 amp regulators on it, a 5 volt and two 12 volts, and a pretty heavy heatsink, even though the heatsink does not really attach to the case, so you have limited heat dissipation capabilities here, but there are a lot of vents here. And it's a dual processor board. It has two 6502s on it. And the way it works is, I guess, the first 6502, and I don't know which one physically exactly that is. I mean, here's one, and here's another. But this has got the DOS in ROM on it. So you don't have to boot an operating system on it. I mean, you can always boot, I'm sure you can boot an upgraded operating system, but you don't need a disk to have this thing come up. And what the first processor does is it handles all the IEEE communications between the computer and itself, and then it actually talks to the second processor, which is a disk controller made of discretes. There's no off-the-shelf disk controller in here. And again, that's probably this processor over here, and that actually generates all the signals that go and control the floppy drives. And again, I looked through it and did some testing, and things still didn't want to work in the beginning. So it was time to do some troubleshooting. Now, the bottom of the case where you have the actual drives, there is the actual, I guess, back here we have the high-level disk controller, and here's the low-level disk controller that generates the signals directly going to the heads and running the motors and all of that. It's got a single board that controls both drives. It's got a little auxiliary board over here that I guess they couldn't fit on here, or this came from the drive manufacturer I don't know, but all of this has is an open collector inverter here that conditions the write protect signals and sends them back through here to the main board. And other than that, again, as I mentioned before, this part was filthy. The drives were filled with stuff, and these capacitors were brown. And there was mud on the bottom of this. Like, if you look in here, there was a coat of mud in here, so water and mud and other materials had come in at some point in time, and that's another reason why I didn't bring it down on the bench and film it, because that was just too disgusting. But on to the actual troubleshooting. So as I got it, it was dead completely. Nothing. There was no power coming in, and the big hint, I mean, there's a power switch back here similar that there's a toggle switch on the back of the unit. And one thing that was kind of an indicator to me that things were wrong was that power switch was extremely difficult to toggle. And on or off, it didn't make a difference, so I went all the way back to the source and just did a static measurement, a resistance measurement on the power switch. And lo and behold, it wasn't, in either position, it wasn't, the resistance was always infinite on it. It was always open. So, well, that was a good place to start. And what do we do now? So the first thing I did was I tried the simple approach. I used the switch and removed it as best as I could and bathed it or squirted IPA into it with something like this. And then started to vigorously work the power switch. And I did a few cycles of that, and the switch started to move a little bit easier. And after about 4 tries, all of a sudden I got continuity on the power switch in the on position. So now at least we were getting power to it. Or at least the power switch would give us some power. I then removed these connectors over here, isolating, well actually, let's see. No, this one I had to leave in because this supplies power to the main PCB. But this is power to the drives, control to the drives, and control to the LEDs over here. And I removed those, and I flipped on the power switch and started measuring voltages at the power out going to the drives and at the chips themselves. And I was getting proper voltages. I was getting 5 volts, the 5 volt logic as required all over the board. And it was pretty good. It was like 5.05 volts I was getting. However, the load was only the main PCB and not the drive, so there could still be surprises waiting for me at this point, but it looked good, and there was 12 volts, 2 rails of 12 volts coming out on this, and without a load, those also measured were very close to 12 volts. So next was the time to make sure that I wouldn't apply power to the drives over here before not having a closer look. I had to remove the drives because of the dirt and getting the mud out from underneath. And as you can see, there's some, it has a disk detect switch that gets pressed when you close the drive door. And things like that were corroded pretty badly, but I checked the switches and they were good. Looking at the main controller board, it also has that white haze on it, which means somebody, again, attempted to clean it, or did clean it, and ended up with the same haze on the board, so it was obviously contaminated with the same stuff that was contaminating the main board. But yeah, all of this got removed. I took the drives out and just manually started testing the drives. What I found that pretty much everything on the drives was seized. The steppers wouldn't move on either drive, and the spindles wouldn't move either. And I took the drive belts off to see if it was the motor, if the motors for the spindle motors were actually seized or not, and the motors turned freely, but the spindles themselves were stuck. So I did spend quite a bit of time taking them apart, and it turns out that the spindles both have they have bearings in them, and those bearings could not be turned. So I took it apart as much as I could. I could not remove the bearings from the metal frames. I mean, if I'd hammered real hard, I'm sure they'd come out. They were press fit, but I didn't want to kill things or damage things even more than they were, and basically put some silicone lubricant, liquid, on them, let it seep in overnight, and then they started to turn. But they were a bit noisy and squeaky, but at least they were turning now. Same thing with the stepper motors. The rails basically were caked with, there wasn't rust on there, but there was a lot of foreign material preventing the heads from moving in and out. So I cleaned that off as much as I could and re-lubricated it, and then put everything back together again. Now at that point it was a bit difficult because most of the wires were disconnected when I got it, and this is not exactly built in a super modular fashion. I mean, things like this were pretty obvious from wire memory where they went, but these connectors here, long story short, were plugged in wrong. And the thing that caused me the most problems was, these are the connectors for the drive lights over here. And notice how I got 0 plugged into 1 and 1 plugged into 0. And I don't know how that happened. I can't logically figure out how these cables could be swapped. I mean, I tested the signals coming from the main logic board, and they seemed to be coming to the correct place, but it just didn't make any sense because I would get drives to do something, but the motor on this one would spin and the light on this one would come on. So after checking the schematics for a long time, I finally took the easy way out and just swapped the drive light connectors, and that seemed to take care of that. Studying the schematics for quite some time, I finally figured out what belonged where, and again, these weren't that hard to figure out, but these were in wrong. And even though these are only the right protect conditioning stuff, these could cause all sorts of havoc when they were plugged in wrong. But finally I got it right. And the way this works is when you put a disc in, when it detects the disc insertion, it briefly spins up the drives. So then I finally plugged in everything with the drives, and inserting a disc into either of the drives spun, but there was a really loud squeaky noise coming from both of them. And as I had suspected before, the bearings, the spindle bearings in both of them, hadn't really gotten cleaned up by all of the lubricant I poured in there. And I think the problem is that those bearings are sealed. So it's kind of like sealed pots. Dirt gets in, but it'll never get out. And it's the same with these. There's probably rust in the bearings inside, and they were just screeching very loudly. But to jump ahead a little bit, after playing around with them for a long time and basically running the motors and putting discs in and trying to get the heads to step and stuff like that, the screeching decreased a lot. And I guess just the fact that they were spinning and whatever lubricant I had put in there got evenly distributed over the bearings, and they're still not very quiet, but at least you can hear yourself think now when the drives run. So what did everything sound like? Well, let's turn it on. And if it finds something wrong on the board, it will give you a repeating blink pattern. So it'll like blink at you 3 times, pause, blink again 3 times, and there's a table that tells you what may be wrong. And in this case, there's nothing wrong. But I did find an instance, I didn't know if that worked correctly. So I looked at a reference sheet here, and it basically told me that if the ROM at location UH1 was bad, that I would get 3 blinks. So that was a good way for me to test if that logic was actually working correctly. So I removed the chip in question, and let's see if it detects. Well, I mean, it's a ROM chip, so I don't know if it's even going to start up, but let's see if it detects something. Yeah. See, it's giving me 3 blanks. So it is actually self-diagnosing itself correctly. So I guess that part works. So let's put this chip back in and see what the drives have to say. The chip has been replaced, and did I bend any pins on it? Nope, we're good. So I don't know if you're going to hear this, but when I close the door, this is what the drives sound like. You can see the door is open, so it's not the top of the spindle, but it's the spindle itself that's making noise. And it's actually not that bad anymore. Again, I apologize I don't have sound recordings of the screeching it made before, but it was pretty horrifying. And the second drive, has actually no, well, it has a little bit of bearing noise, but you can hear the motor louder than anything else. So that led me to believe that at least things are free to move on the drives. I don't have anything seized anymore, and the time had come to test to see if we could actually read something on these. So I hooked it up to the computer, and no love. It does control the drives. They start spinning. They do some seeking, but they're not working. So I spent quite some time looking at schematics and poking around the main board. And after a lot of testing and poking and prodding, I did find that there's two 6532s PIAs in here. And this one seemed to have a stuck output bit, or input bit. I'm not sure what it was, but the bit was permanently high. And I took it out, and I basically tested the socket connection, and the pin was not high anymore. So my suspicion was that this guy was bad. So I replaced the 6532, which was conveniently socketed. Now, before we go on, there is the Achilles heel of this board is that there's a 6530 on here. Where is it? There's 6502, 22, and that one has a house number on it, but I think that's probably the 6530. It's still a PIA, but and these PIAs, they have RAM inside them, and you can route interrupts, generate interrupts, and stuff like that. But the 6530 additionally has a small masked ROM in it. And the reason I say it's the Achilles heel is because if that ROM goes bad, 6530s aren't made anymore. If you can find one, they're not user programmable. So you would have to create some daughter board here that had a 6532 and an EEPROM on it, So pretty much if those things fail, it's usually the end of the road. But I think I had some success with replacing the 6532 over here. So let's bring the computer into play and see if we can do anything with this. The next problem I was faced with is when testing the drives. I mean, fortunately I don't need a DOS disk because DOS is in ROM. So if I turn the Commodore on, you can see it's talking to the drive. It's making the drive do its self-test. So we have comm between the computer and the drive. So I need a disk copy would probably be the best thing to use because I can't test it for booting. But what happened, what I remembered, and I'd kind of forgotten this, when I got the drive, it had two disks inside it. One in each drive, which were used as, I guess, whose function was being a head protector. And I wonder, first of all, let's see if we could read those. Second of all, is there anything on it? So I write protected this one, put it in drive 0 while removing the other disk first, of course. And then spend some time reading the documentation, which is kind of non-standard, but let's see. To get a directory off of drive 0, we do, let's see, DI Shift R drive 0. That's the command for it. Syntax error. What did I do wrong? Oh, DI Shift R drive 0. And it actually read a directory. Now there's nothing on there. There's a file called geninfo. And it's telling me there's 245 blocks free, which is good. We can read on this drive. So what's on the other drive? Disk, I should say. Anything useful on there? So again, DI Shift R drive 1. And lo and behold, there is a bunch of stuff on here. I think these are all basic programs. But looks like both of the disks work. That's quite amazing, actually. So looking at the directory, let's try to load something here. Invader 4.0 at the very end of the list. And again, I spent some time reading the documentation, but you say deload space drive 1, comma, and then the file name, Invader 4.0. Close the quotes. Finds it, loads it, and gets stuck. And it's pretty much hard locked right now. You see, it's kind of weird. The red light stayed on, but the error light is still green. So I guess we should let's try something else. There's something called Pig 1.0 over here. And I'm going to have to power cycle the machine. But we do a deload drive 1 Pig 1.0. So it loaded a basic program. That was pretty quick. Is there anything in here? Yep. So let's run this. Welcome to the Dice Game Pig. So I was actually able to load something, which is pretty good. I mean, just because it's getting a directory doesn't mean that the whole disk is good. It means the directory parts are good, but when it's trying to load code, it fails because there may be errors on it. Even though this was kind of weird because normally I've seen it retry, but this just died. So it may have something to do with where in memory it loaded the file from disk 2, because I think what it does, the program is saved in tokenized form, and then it gets expanded when you list it on here. But I guess we got basic functionality. So I think the real big test here is, one thing I noticed was, let's get out of here, and I think there was a disk copy program at the beginning. And yes, it's called 12 copy disk 1.4. So I think for the ultimate test what I'm going to do is load that disk copy program and put the games disk in 0 and the blank disk in 1. And then let's see, let's load the game. Deload disk or drive 0, and we have 12 copy disk 1.4. So let's see if we can even load that. And there it is. Loaded it. So now if we run this, destination drive number. So for a better look of the salient part, the head of drive 1. So it's asking me for the destination drive, which I will answer with 1. Do you wish to new drive 1? That is Commodore parlance for format drive 1. Yes, we do. Disk name, let's say artifact. An ID for formatting. It just wants a 2-digit ID. Oh, the head's moving. So supposedly it's formatting now. It's still asking me more questions on the computer because, you know, the formatting is done by the PCB on the disk drive unit. And it's asking me, do you wish to alphabetize the new directory entries? That's not complicated, and use the default no. Do you wish pattern matching? No. Copy all files from 0. Yes, copy all files from 0. And then the computer just kind of sits there, doesn't do anything, because I guess what it's waiting for is to see if this is actually successful in formatting the drive. So the head just paused there, probably writing some sort of information. Got a really quiet stepper motor, which I actually don't like because I like to hear the head stepping like on the TRS-80s. Gives you more of a sense of that something is happening. So we should be done any second right now. Let's see. I mean, there's no display on the screen telling you which track it's doing, but oh, it went and did something. So now what it's doing is it's pulling a directory from the source drive, and it's pulling a directory that's taking a really, really, really long time. So it's not even doing any copying yet. It just sits there for a long time and reads, I guess, just the file names of the original disk. And then once it read the directory, it actually starts copying the disk files one by one. Tells us that the read directory was okay, close to was okay. That's the channel it used to read the directory. And now it's going through an even lengthier process of copying all of the files over. So far so good. Both heads are moving. The noise really isn't that bad, and it's getting much better. I think the spindle bearings are self-cleaning right now, or at least I hope so. So, you think it's working? Well, we won't find out till it actually copies all of the files over, but it actually looks pretty good. It was worth cleaning it all up. Again, I'm sorry I didn't film it. I should have just filmed a short clip of when I dragged it out of my car. Should have opened it up and showed you the mess inside. And I'll do that next time, but things seem to be working well. So let's go offline here and wait for a few hours, and then actually check the disk that we newly created and see if we can load anything off of it. Well, that took almost a half hour, but it completed without reporting any errors. So as a last try, let's load something off of the newly created disk. Blah, 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 blah. That's all great, but it's not really telling us what keys to use. Well, anyway, do you understand? No, I don't. Oh, so it just repeats it. Yes. There you go. Well, there you go. There's Lunar Lander. So the drives back, they do seem to be working. And I think what I'm going to do is copy this disk several times, because it seems that when you're exercising the drives, the copy just exercises everything, and they're getting a little quieter, and they seem to be working okay. So there you have it. Well, thank you for watching. Floppy drives are still important, even though Linus T just decreed that floppy drives are no longer any good and should be considered obsolete. Yeah, sure, you don't want to use floppy disks, especially not 5 1/4, to store your legal documents or pictures. But I think it's important to maintain working equipment, because I think there are lots of untold treasures still hiding on a floppy disk somewhere, and it's always good for us to have equipment that is still able to read them. I think this also attests to the toughness of floppy disks. Remember that the floppy disks in here basically were in this unit with all the filth and weather exposure and everything, and both of the floppy disks still worked. So not bad. I got another disk-based system now that works. So a thumbs up would be appreciated, even though I can already see the comments about, I can't believe I watched you format a floppy disk. But come on, that's the fun. That's all part of this. And make sure to subscribe, because we'll be restoring lots more of this stuff and keeping the landfills a little bit less crowded than people taking equipment like this. I mean, come on, taking a bunch of pets and disk drives and just throwing them into the trash. Oh well, we'll see you next time.